Hey, welcome to this next video, guys. I'm going to be talking today about equivalent equations. And again, kind of going for analogies to help you understand them a little better. Is it recall that we can make equivalent fractions by multiplying the numerator and denominator by the same number. So, for example, if I had 4 over 9, I could create an equivalent fraction by maybe multiplying the top by 3 and the bottom by 3, and that creates an equivalent fraction of 12 over 27. Okay, and so in the same way, well, let's just talk first. Both of these equations here, this one here and this one here, represent the same value on a number line. Okay, so they're exactly the same fraction, just represented in a different way. In the same way, we can create equivalent equations by carrying out the same operation on both sides of our equation. Okay, and equivalent equations are true for the same substituted variables. So if I was to have an equation that was 2x plus 3 equals 7, if I could just say that an equivalent equation to this is 4x plus 6 equals 14. Okay, if we substituted a value in here for the x, then it's going to come up like they will be equivalent to each other. They'll say the same thing. Okay, we'll sort of see how this works as the video goes through. Right, a couple of things for you to know is that the main operations that you're going to be working with in equations this term are adding a number to both sides, okay, subtracting a number from both sides, multiplying both sides by number. Now this is important, the multiplying both sides by number, that you need to multiply that number against each term in the equation. It's essentially like creating some brackets and multiplying out by the front. You shouldn't really be needing to do that at this stage, so don't freak out too much. Now there's no point multiplying by 0 because you won't create a solution. You'll just end up with 0 equals 0, and that won't help anybody. You can either, and another operation you can carry out is you can divide both sides by some number. Certainly not 0. You may not divide by 0, it is undefined, can't do it mathematically. Another thing that you can do is you can swap the sides of the equation. So you can just switch from left hand side to right hand side and it won't make any difference. You'll still have exactly the same equation. Now, to solve an equation, you create a series of equivalent equations that become more and more simple until you are left with the variable and its solution. Now, one way that I'd kind of like you to think about it is that sort of equations kind of like an onion, you know? And onions have, as Donkey says on the Shrek, onions have layers, and you want to pretend that in the middle here is X. Okay, and the act of creating these equivalent equations is sort of peeling off the layers of the onions until all we're left is the X that we're after at the middle, and then you have your solution. Okay, hopefully you sort of see that analogy working as we sort of go through these. Okay, right, a couple of worked examples that I'll try and fly through. I'm trying to keep the videos down a little bit now. So we want to solve the following equations. Here we have 2x plus 1 equals 7. Now I'm going to demonstrate to you the way that I'd like to see your equations being done. You're going to possibly be annoyed, but this is setting you up in good stead for your algebra later on. Maybe once you're extremely confident at this, never making errors, you can start to take shortcuts, but at the moment I want to see you doing full steps, full working all the time. So we have 2x plus 1 equals 7. Now, the first thing I want you to think about is that here is our term with the variable in it. Essentially, we want to do some stuff to just have this by itself. Now, kind of ask yourself, what is ruining our party of just having the 2x? Well, this 1. Let's get rid of it. How do you get rid of, what this is doing is plusing 1. How do you undo adding 1? You undo it by subtracting 1. So we're going to subtract 1 from both sides. Subtract 1, subtract 1. So 2x plus 1, take 1, leaves us just with 2x, equals 7 take 1 is 6. Then we're going, well, here's our x just here by itself now. How do I get that x by itself? Well, 2 is stopping me, and 2 is multiplying against the x. Remember, there's a little multiplication symbol in there that we don't write. So to undo 2 times something, you should divide by 2. So divide by 2, divide by 2, and we will end up with x equals 3. Okay, so that is the unique solution for this equation. Okay, if we substituted the 3 in at the start, 2 times 3 is 6, plus 1 is 7, equals 7, it's true. Okay, right, next one. 5z minus 3 equals 17. So rewrite that, 5z minus 3 equals 17. Okay, again, it's probably a good idea at the start to sort of highlight your term with the variable in it and think, what have we got to get rid of? Well, here we have a subtract 3. So to undo subtraction of 3, you need to add 3. Okay, so we're going to add 3 to both sides of the equation. Whatever you do has to be done to both sides of the equation. And 5 said, take 3 plus 3, because remember, subtract 3, negative 3 plus 3 is 0, so that's why this works, okay? So we're left with 5z equals 17 plus 3 is 20. And again, here's our z, left, that's what we want. The 5 multiplied by z is what's stopping us from having z by itself, so we need to divide by what? By 5. Okay, divide by 5, and we're left with z is equal to 4, and there is our unique solution. Just quickly, one more to finish. This is sort of written around a different way. Oh, there's more than one. I'll just quickly fly through these. I don't want to make the videos too long. So 53 take 2x equals 3. Right, here is our term with the variable 2x. This 53 is stopping us. Now, I want you to remember that there's kind of a plus here. We don't write it, wouldn't make any sense, but that means that to get rid of this positive 53-ness that's on that side, we have to subtract 53 from both sides, okay? So, we're going to subtract 53, and we're left with negative 2x. Okay, that subtraction sign doesn't go with the 53, it stays and makes this a negative 2x. 3 minus 53 is negative 50. Okay, right, now this is what we want here, the x just here, and we have, it's being multiplied by what? Well, by this number, this negative 2 here. Okay, remember that's negative 2 times x. So we should probably divide by negative 2. Divide by negative 2, and we're left with x is equal to negative 50 divided by negative 2. So negative divided by negative gives you a positive. So 50 divided by 2 is 25. Okay, remember you have your calculators now, and so there's no real excuses for making a silly error on negative 50 divided by negative 2. Alright, lucky last little equation for us to have a look at, and it is here, 14 equals 8x minus 2. Now this one's here just to demonstrate to you that it doesn't really matter which side your variable is on. So 8x take 2, our 8x is what we want on its own, so we've got to get rid of this subtract 2. So we do that by adding 2 to both sides. So we get 16 equals, oops, I'm going to try and keep my colours consistent. 16 equals 8x, and we just want the x, so we've got to get rid of this multiplying by 8. To do that, we divide by 8, and we're left with 2 equals x, okay? You can rewrite that as x equals 2. There's no problem doing that, because remember, switching the sides is an operation that we can do, okay? So that's just a quick rush through having a look at how equivalent equations work and how you use them to solve equations and find solutions. So please go through those again if you need to. Make sure you've had a shot at some of those examples and followed them through, and bring any questions with you along to class, okay? Thank you.